Hey, AP Stats, Mr. Ellinger here with the answers to the practice quiz that I posted and sent out on Sunday, the 21st. So here come the answers. So when would be appropriate to use a histogram rather than a bar chart? The big thing here is the difference between quantitative and categorical. A histogram is a quantitative thing with a bunch of bars, but a bar graph is for categorical data. So I have to look at the data. Favorite sport, categorical bar graph. Gender, same. Height. Height is quantitative. That's the one that I would use a histogram for, not a bar graph. So that's just a question of knowing what's quantitative, what's categorical, and which displays we use for each one. The histogram shows which of the following could be Q1. Okay, so let's think about this. So we've got 50 pitchers, and so the median would be you take the 50 pitchers and you divide them up into 20, into 25 and 25. Okay, cool. That's the median, would be the average of those two. I don't need to figure that out. So then the Q1 is the median of the bottom half. So I got to look at the bottom half and say, what would the median of the bottom half be? So there's 25 pitchers there. I guess I should be drawing this, and that would be a little bit more helpful. So there's 25 here, and there's 25 here, and 25 there. And to find the median, you'd have to average the two middle ones, but I don't need to do that. I need to find Q1, which is the median of the bottom half. Well, there's going to be 12 pitchers here and 12 pitchers there, and just one that's sitting in the middle. So what that tells me is I need the 13th pitcher, because that'll divide the 25 up into two groups of 12. Since that's an odd number, then there's one single median in the middle. So 13th. So how many do we have? We got 2 here. We got 2 here. So we're up to 4. 3 here. So that's 7. I'm using the bars on the scale on the side. 7. 4 there. So that's 11. So it's somewhere in this range between 2.06 and 2.3. That must be this one. Next one. Categorical stuff. Here, there's a two-way table. Excellent. Okay, what are the individuals in this one? So the collection of these 80 things are the games that they played that season. So the individuals are the games. Boom, boom, boom. That's what these 80 things are their 80 games. And then what's the variable? Well, it could be a win or a loss, and it could be that they had no rest, short rest, or long rest. And so the variables, tricky little question here. So the choice between the two ones. The variables are the amount of rest and the outcome of games. All these little individuals, those are the different values that the variables can have, but those aren't the variables themselves. Like the variable is the concept, the thing that you're asking about, but all the different individual answers aren't variables, they're just answers. Next one. What proportion of the games did the Cavaliers win and have short rest? So win and short rest. So that was 34. And so notice that they had a bunch of 34s there, but it's 34 out of the 80 games they played. Now, one thing to know is even if they gave you decimals on this one, you want to make sure to always write your answer, write your workout, and which could just be showing what the fraction is and then showing what the decimal is for the answer. That would be fine. But they were nice on this one, and we don't have to work it out. So that's that. Based on the table, which of the following is the best evidence that there's a relationship between the amount of rest and the outcome of the game? So this is getting into the idea of association. Is there a relationship between these two variables? And the way we tell is if there's a difference between the win-loss rate depending on how much rest they have. So like I can look at the percentages here and didn't mean to do that. And I'm just going to write it to the side. And so for none, then how often did they win? It was 11 out of 19. Yep. In the none category there, in the none value, 11 times they won out of 19. And so with none, it was 58% win to 42% win. Now, if there's no relationship between the amount of rest and the results of the game, then we'd expect that when there was short rest, they'd still win about 58% of the games. And if they had long rest, they'd still win 58% of the games. If there's no relationship between the variables, then changing one variable doesn't do anything to the other one, and the proportions would stay the same. So now I can look at the short one, which is 34 out of 44. And so for short, it was 34 out of 44, which is 77%. Again, if this was free response, I'd write my work, but I'm just doing multiple choice here. So, whoa, there's a big difference in how often they win when they have short rest. And I could work out long rest too, but that's a big difference from 58% to 77% winning and 23% losing. All right, now I got to find the option. Based on the table, which of the following is best evidence? The number of games is not the same. No, that's not true. The number of wins, it's not about the numbers, it's about the proportion. The proportion of wins is not the same in each rest category. That how often they win changes depending on the amount of rest. Okay, scores, roughly symmetric mean of 81, and a range that's from the bottom to the top is 9. Okay, one student was absent and his score wasn't excluded, but now they add the 83 on there. So the mean was 81 and the range was 9, and it's symmetric. So it's going to be roughly, the bottom is roughly going to be, 76 or so, and the top is going to roughly be 85. I know that's not exact, but it's going to be about that. Okay, when you add the 83, the 83, that's within the bottom to top, and so the range isn't going to change. The smallest value and the top value are still the same value. So the range is not going to change. The range is going to stay the same. And woohoo, there's only one that gives me that choice. Next one, stem plot. This is just, can you read a stem plot? Values below x beats per minute should be considered outliers. What is the value of x? So we've got to decide what the outlier is. Okay, this takes a little bit of work now. What we need to do for outliers, I'm going to write it and I'm going to pause it so I do the work. The outlier formulas, as I mentioned, are that you find first find the IQR, because you're going to need that. So find Q1, Q3, and the IQR. You're going to need those things. So we're going to have to do that on this. And then second is then the outlier borders are the fences, what I like to call it, are Q1 minus 1.5 IQRs and Q3 plus 1.5 IQR. Okay, you can figure out the Q1, Q3, and IQR yourself. I'm going to do it while I pause the video so I don't take up the time. Okay, first I did the same trick I did before where I divide the 26 into 13 and 13, but I need Q1 and Q3, so that the Q1 is the median of the bottom half, Q3 is the median of the top half. And so I said, all right, here's the median would be in the middle here, median. And so Q1 is going to be the 7th number because the 13 in the bottom half will be divided up into 6, 6, and 1 in the middle. So the 7th number from the bottom is Q1. So I counted up 1, 2, 3, 4, 5, 6, 7, and I got that Q1 was 64. Did the same trick for Q3, got that was 76. IQR is just the difference between them. I'll even write that down just to remind you, is Q3 minus Q1. It's how far apart are the quartiles? How far apart are they? So you're just subtracting them. And so how far apart are those? They're 12 apart. And so you go from Q1 and you say, okay, how low does it need to be an outlier? Well, you go 1.5 IQRs down. And then you do the same thing on the high end. You go from Q3 and go 1.5 IQRs up. Notice we never use the median itself in these calculations other than to locate it to help us find Q3 and Q1, but we didn't find what the actual number was. So the low border was Q1 minus 1.5 times the IQR, which is 46, and we have an answer. Next one, if an additional student with a heart rate of 106, 106 would be way the heck out there, then how many more stems need to be added to the stem plot? Oh, tricky. Okay, so if we added 106, then we'd have to add the 90. So notice this is what's called a split stem plot. It's when they divide it up. They divide it up. And so the first, they repeat each initial stem. And the first one would be for anyone's with a units digit from 0 to 4. So like 60s are a little better because we've got them there. So 60, 61, 62, 63, and 64 are there. The second time we write the 6, that has 65, 66, 66, and 68. So that's the purpose of that. So what would we have to have? We'd have to have one for the 90s from 0 to 4. And then we'd have another one with the 90s from 5 to 9. And then we'd have to have another one for the 10s from 0 to 4. And then another one for the 10s from 5 to 9. Correct answer is 4. How are we doing? 10 minutes. Woohoo. Okay. About how many students scored 85 or below. Well, so 85 is Q3. The 5-number summary is the min and Q1 and the median and Q3 and the max. So 85 is Q3, and so that means it's at the 75th percentile. You got 25% above and 75% below, about, because you have to count them, and so it's an approximation. So about how many students scored 85 below, about 75%, but that's 75% of 300 students. So it's 75% of them scored from here or below, and 75 times 300 is 225. So, there's 75 students down here, and then 75 here, and 75 here, and 75 there. And so it's about 225. Boom. How low would the lowest score in the last problem have to be considered an outlier? I put an extra outlier in, but just in case. So Q3 minus Q1 is 20. That's the IQR. They gave us Q1 and Q3 with a 5-number summary. And so the low end would be Q1 minus 1.5 times the IQR, which is 35. Next one, 11.5. Oof. The bar graph is for people assigned to a treatment A in an experiment. Which of the following bar graphs for people assigned to treatment B would indicate there was no association between treatment type and outcome? And it would be if it was exactly the same, right? If changing one variable doesn't do anything to the other one, then there's no association, there's no relationship. It's when changing a variable then influences the other variable, that's when you've got an association. How is this graph deceptive? They didn't include 0, and so this length here is 15, but this length here is 24, and so it makes it look like Trump had way more appellate judgeships confirmed, and he had more. 19, 18, 18, 16, 15, 24. It's bigger, but they've made it look like it's many times bigger when really it's then the highest one, it's about 20% bigger or something like that. And so they didn't include 0. And by shortening them up, we make this thing look like it's nearly nothing when really it's over half this one, right? 15 is over half of 24. So, and the one problem with this one is it doesn't include the fact that this was one term and this was 2. So that's a little interesting. But the graphic is deceptive because that's the analysis. But the graph is deceptive because of that. Compare the distributions. All right. Yeah. I'm not going to make it right. Oh, kind of close. All right. So compare the distributions. I'm going to pause it and I'm going to compare the distributions for you. Okay. So I compared the centers. I said, looking at the centers, the median number of bacteria is much higher when you use nothing compared to the other two, which have much lower medians. Median was about 50-something bacteria or something. Is it number of bacteria? Number of bacteria colonies. So notice how I discuss how I knew what the center was, and I used context. Writing your answers with context is extremely important in this class. If you just said the median's higher for none, yeah, I'd probably mark you down for context on that. Give me the situation that we're talking about, the real life situation. Once you've done that once, you don't have to repeat it a bunch of times. So I was much shorter in this one. The spread is also much higher because you can see the IQR difference. The IQR, remember, is Q3 minus Q1. It's how wide that box is. So that's 90 to 40. That's 50 something. Whereas the other boxes are much smaller. So the spread is much bigger for none also. There's no apparent outliers because remember, when you have an outlier, you mark it with a little asterisk instead of extending the bar all the way out to it. You extend the bar out to the last non-outlier. Finally, I have a quick answer here that I'll just leave up. You can pause it for how you could tell. So, I didn't answer the question. Whoa! And so so therefore the median on this one is 6, and therefore in this one the median is 7. Whew. Just finished it. Okay, that's the answers. We'll have some more supplemental stuff to help you out later. Bye.